The fourth application of differentiation is stationary points. Now, actually, stationary points is something that you are familiar with. It talks about there are three kinds of stationary point. As you can see, point A, which is a maximum point, is a stationary point. Point B, which is a minimum point, is a stationary point. Then something new would be point C, which is called a point of inflection. Now, what does stationary point means? It means the point where if a particle travels from here, when it reaches A, it is stationary at this very moment, just for a second only, okay, before it turns downwards. And then when it reaches B, it reaches stationary for the very moment before it goes upwards. And when it reaches C, that it reach a stationary moment before it goes upwards again. Okay, so at these points A, B, and C, when you draw a tangent to the curve, you realize that the tangent is a horizontal line, and in a horizontal line, the gradient of a horizontal line is equals to 0. So when you talk about stationary point, when the question is asking for a stationary point, okay, you just need to say that dy dx is equals to 0. Okay, before that, let's talk about a little bit about the notation. That means if you have y and you differentiate it one time, it is called dy over dx. If you differentiate it another time, it's called d2y over dx squared. Okay, d2y over d squared is just means differentiating y two times or differentiating dy dx one more time. When the question gives you fx, when we differentiate one time, it calls f prime x. If you differentiate it another time, it is called f double prime x, so on and so forth. Okay, so again, different stationary point means dy dx equals to 0. So I have this equation here. All I need to do is to differentiate by using my product rule. Okay, this is the u, this is the v. Dy dx equals to, keep u 2x, differentiate v, 2 bring down x minus 3. Okay, plus keep v, x minus 3 squared, differentiate u, I will get 2. Always look to factorize, as well as factorize. I take out a 2 as well as a x minus 3. I keep a big bracket on the inside. I'm left with 2x plus x minus 3. Okay, so I will have 2 bracket x minus 3 as well as 3x minus 3. Factorize this again, I will have 6 because I pull out the 3x minus 3, x minus 1. Always make your dy dx simplified first. Now I can say that for stationary point, my dy dx is equals to 0. 6 bracket x minus 3, x minus 1 is equals to 0. I will have x equals to 3 or x equals to 1. Okay, sometimes the question may ask for coordinates. If the question wants coordinate, you sub it into your y equals to 2 bracket 3. Yeah, 3 minus 3, that will be equals to 0. And the other one will be y equals to 2 bracket 1 minus 3 square. 1 minus, that's negative 8. Okay, so if the question wants for coordinate, then we say that this is 3 comma 0 as well as 1 comma negative 8. Okay, this is how we find the x values for stationary points.